Hi everyone, in today's lesson we're going to talk about how to find a derivative. Derivatives are all about slopes. So let's first recall a few things about finding slope. We can find the slope of a line between any 2 points using the following formula, where slope is the change in y over the change in x. So the change in the y value over the change in the x value. So we're just going to subtract the y's, so I will call this x1, y1, and I will call this x2, y2. So we can say that slope is change in y, so y2 minus y1 over x2 minus x1. So my y2 is 3 and my y1 is negative 1. So 3 minus negative 1 over my x2 is 4, and my y2 is negative 2. So 4 minus a negative 2. And when you simplify the numerator, you should get 4. And the denominator, you should get 6. And when you reduce it, you get 2/3. So we found the slope between these 2 points on this line is 2/3. Now sometimes I could ask you to find the average slope between 2 points on a curve. So we can find the average slope or average rate of change between 2 points on a curve by taking the slope of the secant line that joins those 2 points. Now let's just recall from geometry, a secant line is a line that hits something in 2 points. So if I were to connect these 2 points right here, the line that I make is a secant line because it hits the curve in 2 points. So if I want to find the average rate of change, we're just going to find the slope between these 2 points. So again, we can make this x1, y1, x2, y2. So change in y over change in x. So my average rate of change is y2 minus y1 over x2 minus x1. So y2 is 3, y1 is 0, x2 is 0, and x1 is negative 3. So it's 3 over 3, which reduces to 1. So my average rate of change between these 2 points is 1. Okay, but what if I ask you to find the slope at one single point on the curve? Now this is called the instantaneous rate of change. Say I want to find the slope at this point right here. Now I'm going to explain why the formula is what it is. I will explain it in class. It's a little too difficult for me to explain on the video, but I just want to say to find the slope at any given point or to find the instantaneous rate of change, we need to use this formula. And this formula is the limit definition of a derivative. So what we're going to do is to find the derivative, we're going to take the limit as h approaches 0 of this. And the notation that we use to find the derivative is f prime of x. Other notations that we use is dy over dx. And f prime, they mean the same thing. They mean to find the derivative. Now this should look familiar to you because we've done this before when we've evaluated functions. Now I'll explain why all of this comes from tomorrow in class, but let's just try to get the definition down and how to use it. So let's move on to the next page. Okay, so it says, for example number 1, using the limit definition, find the derivative f prime of x of f of x, which is equal to this. So what we're going to do first is write the formula. So f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Now remember, if I want to find f of x plus h, I'll even write it over here, f of x plus h. That means everywhere I see an x, I'm going to put an x plus h. So 2x plus h squared minus x plus h plus 5. So we can start here by double distributing. So I'm going to write it over here a little bit. So we have 2x plus h times x plus h minus x plus h plus 5. So I'm going to try to double distribute this first. It'll be x squared plus xh plus xh plus h squared, which I can simplify these two to 2xh plus h squared, and I can bring down the x squared. So all of this times 2 minus x plus h plus 5. So we can distribute. So 2x squared plus 2xh, plus 4xh plus 2h squared minus x minus h plus 5. And I'm just going to erase this and make it look a little bit neater. Okay, so now that I have all of this, what I'm going to do now, that is my f of x plus h, I'm going to subtract f of x. And now this is my f of x function. So I have the limit as h approaches 0 of 2x squared plus 4xh plus 2h squared minus x minus h plus 5 minus f of x. And this is my f of x function. So 2x squared minus x plus 5 all over h. So we're going to take the limit as h approaches 0 of 2x squared plus 4xh plus 2h squared minus x minus h plus 5, and we're going to distribute, minus 2x squared plus x plus 5 all over h. Alright, now the fun part. I can cross off a 2x squared with a negative 2x squared, a negative x with an x. This should be a minus 5, so I can cross off plus 5 and minus 5. So I'm left with the limit as h approaches 0 of 4xh plus 2h squared minus h all over h. And now I can simplify by dividing all the pieces by h. So these two cancel. This one cancels with one of these, and this cancel to 1. So now we have the limit as h approaches 0 of 4x plus 2h minus 1. And now I can substitute my 0 with a direct substitution. So we take the limit as h approaches 0, and I plug in 0. So we have 4x plus 2 times 0 minus 1. So simplifying all of that, I get f prime of x, or my derivative, which is equal to 4x minus 1. So that is the derivative, or the slope, for any given point at this curve. So what does f prime of x equaling 4x minus 1 mean? It means that for the function f of x equals 2x squared minus x plus 5, the derivative at any point is 4x minus 1. So for example, when x equals 4, the slope, or the slope of the tangent line, which is another name for derivative, so we could just say derivative, is what? So what we're going to do is we're just going to take our derivative function and plug in 4. So 4 times 4, minus 1. So 16 minus 1 is 15. All right, let's see what you can do on your own. So we'll start by going over this one tomorrow. So what I'd like you to do is, using the limit definition of the derivative, find dy dx, which is the same thing as saying f prime. Find the derivative given this function. So we're going to start with the formula, the limit as h approaches 0 of f of x plus h minus f of x all over h, where this is your f of x function. So try to see if you can model the problem we did before and solve for the limit, or the derivative, as h approaches 0. Alright, if you have any questions, do as best you can and we'll answer them all tomorrow in class. Have a good night.